Hello guys, how are you? I am Yanil and I'll be helping you with chemistry. Today we'll be looking at a normal organic chemistry topic. The basics of it we'll be understanding about how an organic reaction occurs. What are the things that are going to get involved in that reaction mechanism? Apart from that, we'll also look at the intermediates and the reagent that makes the reaction occur. We'll also try to cover up some of the reaction mechanism and we'll see substitution and elimination majorly. So let us start. Let me share the screen and then we'll continue. Fine. So we have the screen. I believe you're all able to see the screen clearly. And started then. So as I was telling you, any organic reaction occurs in a particular manner. And in an organic reaction, there would always be a substrate. A substrate is something that is an organic compound with which we will be working. For example, an alcohol. For example, aldehyde, ketone. All these are the organic substances. Anything you can actually have here, which is organic in nature, can be considered as a substrate. Now, to this substrate, there will be something that is acting upon. That is the reagent. Many times the substrate won't be reactive, and at that condition this reagent is something that makes attack on the substrate and makes the reaction initiate. So this reagent is something that you would be basically focusing on in today's topic. The reagent can be an acid or a base, because this is having a capacity actually stop a reaction or initiate a reaction. Apart from acid and base, which you already know from your junior standard, we have nucleophiles and bases. We have something called as nucleophiles and bases. We'll talk about what is a nucleophile and base. Apart from this, oxidizing agent and reducing agent can also be considered. Oxidizing agent and reducing agent will also be considered as another substance. So when the substrate gets attacked by this reagent, when the substrate gets attacked by this reagent, the reaction will proceed. Okay, and in this process, what we will be getting is, for a short span, you'd be getting something which is very unstable. But this unstable thing will decide the progress or the final product of the reaction. This substance, which we will be getting for a short instant, will be called as an intermediate. And intermediate is something that you might have already heard of. Like, you can have a carbocation, free radical, and you can also have carbene and carboanion. All these are the kinds of intermediate that we will be discussing. May not be in today's class, but later on we'll be observing that. Apart from the intermediate, you can also have, you will also have, obviously you will be getting a product in this whole process. So our concern today is to understand about these reagents. We're talking about the reagent that you'll be having in this organic reaction. Okay. So let us look at this thing. I believe we have an idea about what is an acid and a base. So it's better to start from a nucleophile. And let us start with it then. A nucleophile. So what you guys think is a nucleophile? As its name suggests, philic means affection, nucleo means nucleus. So something that has affection towards the nucleus will be called as a nucleophile. What are those things that can actually have an affection towards the nucleus? In the nucleus, you have positive charge. What will attract or what will seek a positive charge? Something that itself has a lot of electron density will be the one that seeks a positive charge. For example, you take OH minus. OH minus is something that has a lot of electron density. If you guys would know, oxygen will have a lot of electron pairs around it. And because of so many electron pairs, it can easily give its electron pairs to anything that seeks electron. So it is a very good nucleophile. Okay. And when nucleophile approaches anything which has a positive charge, it quickly makes an attack on that and it substitute to that. Depending upon the situation, it can actually work. So nucleophile's major work is to attack a center which seeks electron and gives its electron to that center. By doing that, it is going to convert this molecule into this. Okay, so this is the action of a nucleophile, something that has a lot of electron density, and it is capable of giving electrons to another substance that seeks electron. This substance here seeks electron. Okay, this substance here seeks electron pair actually, and this substance has excess of electron. The substance that has excess of electron is what we know as a nucleophile. Okay, so this OH minus here is going to give the electron pair and will make a base. But wait, we have already seen this OH minus in another thing also. This OH minus was the same thing that you were actually getting if you take NaOH. Just imagine, or remember what you would have studied earlier. If this NaOH gets broken down in water, it gives you Na plus and OH minus. Doesn't that make it a base? It does, right? So it is actually a base. But then why is there a new name? Why is there a new name which we use to call it by that is nucleophile? There must be another issue here because in chemistry you don't have things getting to confuse you. You need to understand them. If you understand them, you'll be able to understand the idea, like why is it actually there? What is the thing that is working there? Okay, so let's understand that and try to find out why and how is this nucleophile and a base. How this OH minus can actually act as a base as well as a nucleophile. We'll look at that and try to understand that. So we'll look at both the things and both the behavior. So let us start our work today with the comparison of a nucleophile and a base, and what thing that actually makes a nucleophile and differentiate it from a base. We'll also look at that. So let us take the same substance, OH minus. OH minus, whichever thing gives OH minus can obviously act as a base, and obviously if you look at OH minus, you find that it has a lot of electron density. That again makes it a nucleophile. I'm not elaborating about nucleophile here. We're looking at the nucleophile part again once we understand the difference. So let us start understanding what and how nucleophile and bases are different. And how can you be sure that the thing that you have, the activity that you're seeing, is that of a nucleophile, not of a base? The first and the major difference that comes between a nucleophile and a base is the way the substance reacts. So let's say you have OH minus. Let's say you have OH minus and you are trying to react it with something like this. Okay. I believe you all familiar with CH3Cl, this kind of molecule. Now the Cl is a very good leaving group. You can take many other leaving groups here. I believe you have an idea of other leaving groups also. I'll also give you an idea here. We'll have a simple leaving group. Okay. This molecule which I'm drawing over here is one of the very, very good leaving group that you can find around. This molecule here. This molecule is one of the very, very good leaving group that you can actually find. It is called as no-silate. Okay, so you just keep this thing there. It will act as a very good leaving group. Now this molecule is not our concern. Our concern was to understand about how this base or a nucleophile will work. So let us move it aside. This is not our concern for today's class. We'll look at it later. Coming back to the point which we were discussing here. The attack varies in a base and a nucleophile. Nucleophile seeks any positive center and it attacks that. Any center that has capability of accepting electrons. You know that this is chlorine is partially electronegative. I mean, is electronegative, and because of that, this bond is highly polar. And chlorine gets a partial negative charge, while this gets a partial positive charge. This makes the central carbon partially positive, and that is why when this molecule sees that there is a necessity of electron donation, it jumps to that, which obviously makes this other molecule move away, the leaving group move away, and the leaving group leaves that position. And you get the product that is expected to be formed produced or formed via nucleophile by the activity of a nucleophile. So what we will be getting is CH3OH, and this is the product that you get when you act or when you see a reaction shown by a nucleophile. On the other hand, if the same OH minus is acting as a base, if the same OH minus is acting as a base, what it is capable of doing is it will just extract the hydrogen. Let us just look at another condition here. Okay. CH3, CH, H, H, CH3, and CH3. So you have a lot of things here. Now in this case, okay, you might think that the attack would still happen in the same way, but it is not going to happen the same way. The reason is the substance is having a lot of bulkiness. These groups that are there, they're very bulky. Right? You just imagine that three people are sitting in a chair and you are trying to go there, disturb these three people. Just imagine this condition. There are three people, okay, sitting in a chair, talking to each other, enjoying their lives and time, right? So what happens is when another person tries to come over there, obviously they'll feel a lot of push, right? It will be very difficult for the next person to come and sit in that position. So that is what we call a steric hindrance. In actual, the actual steric hindrance has much to do with the van der Waals radii, that we'll be discussing later. So this is stopping this process to occur in the same way as it has occurred in the previous one. So here things happen differently. Instead of taking the other thing, instead of taking the molecule, instead of replacing that thing, here what OH minus will do is it will take out the acidic hydrogen. What is acidic hydrogen? The most electropositive hydrogen. In this case, all the hydrogens are same, so we don't need to be thinking about that. So this will extract this molecule from here, and because of that, this will shift over here, and this will leave. And understand one thing: this hydrogen which it is trying to take out is very small. Taking out a small substance would not from any position would not have so much of repulsion or this hindrance, steric hindrance taking place. So it can actually abstract the hydrogen. That's where this nucleophile and base differs in that way. So the product that gets formed in this process, are H2O plus CH3, C, double bond, okay, let me properly make it, CH3, C, double bond, CH2, and then another CH3 molecule. So this is the product that will actually get generated. You've just observed the difference between how the activity of a nucleophile differs from the activity of a base. This is the basic difference, although there can be other differences as well. For example, you just take, as I was telling you about this steric hindrance, right? So just imagine that there's three people. Now that you have understood the story, so let's not talk about the story again. What we need to understand here is, let's say if there are two things and they're coming closer to each other. Obviously, they have attractive forces. Electrons will be attracting the protons. Protons will be attracting the electrons. They try to come closer to each other. But once they come closer, protons and protons will start repelling each other. Right or not? Protons and protons will start repelling each other, and this causes them to not come any closer at a particular distance. The distance when they are very close to each other and more stable, where there's repulsion and attraction, balances each other, is called as van der Waals distance. You have already studied this in chemical bonding in another chapter, so we will not focus more on that. This is called as van der Waals distance. Now the problem and the point was, when something comes as close to the van der Waals distance, or closer than the van der Waals distance, what happens? When another molecule tries to come here and it has breached that distance, the minimum distance that would have been made it stable, that would be required to make that substance stable. Something moves closer than that, you would yourself be able to understand what will start dominating. Obviously, the repulsive force will start dominating, and this repulsive force doesn't allow this to enter there. And that's what was happening. That is what was happening when the three friends were sitting in a place, and another person tries to join them. It will not be easy for them to be there, and that is what was the problem. I believe you would have understood that. So this is what will actually happen here. Now the point is, in case when you take a nucleophile needs to go and get substituted to that position, and it has to attack a place. It has to attack a place which is already crowded, right? Like you have seen that there is the CH3 and has trying to attack the CH3. So do you think it will be easy for this molecule to get to attack that place when everything is there? It will obviously be difficult. Just keep this.